Hi, this is your host. Today's episode, we are going to talk about the Chicxulub Crater. This is a crater that was formed 66 million years ago when a large asteroid or comet impacted near the Yucatán Peninsula of Mexico. It's also the reason why there aren't any dinosaurs alive today. This impact unleashed tremendous amounts of energy, triggered massive earthquakes, tsunamis, and set off a chain reaction of climatic devastation that not only killed off the dinosaurs, but 75% of all species on Earth. But what if we could learn more about what exactly happened here? Because recently, scientists have been back at the crater to try and get some answers. They found something surprising. They found evidence of one of the largest energy releases in the history of our planet, possibly even larger than the Big Bang itself. And now with this latest discovery, we might be able to understand what happened after the asteroid struck and why it was so devastating. The Chicxulub Crater lies beneath the Yucatán Peninsula, but its true location was unknown for many years. It wasn't until the late 1970s that scientists discovered that the geological features here were consistent with an impact event. And since then, researchers have revisited the site numerous times to learn more about it. The impactor was about 6 miles or 10 kilometers in diameter, and it struck the Earth at a speed of approximately 25,000 miles per hour or 40,000 kilometers per hour. When it hit, the impact released between 30 and 40 trillion tons of rock into the atmosphere, which was roughly 3 million times more energy than was released by the atomic bomb dropped on Hiroshima. But unlike the atomic bomb, whose radiation and thermal effects were largely localized, the Chicxulub impact sent debris high into the atmosphere and triggered multiple catastrophic effects around the world. For example, the impact heated the surface of the Earth to as much as 2,600 degrees Fahrenheit, which is nearly 1,500 degrees Celsius. It shook the Earth with earthquakes that reached magnitude 12 on the Richter scale. In contrast, the strongest earthquake ever recorded had a magnitude of 9.6. The impact also generated a tsunami, with waves reaching up to 100 feet or 30 meters high, and these giant waves inundated coastal regions across the globe. In the aftermath, a layer of ash and debris spread across the North American continent, blanketing the landscape and burying entire forests. But despite all of this, some creatures survived, including birds, small mammals, and certain species of reptiles. For instance, the asteroid wiped out terrestrial crocodilians, but left their marine relatives largely intact. And while most dinosaurs went extinct, a few groups, such as the flying birds, survived. It's believed that these survivors adapted quickly to the changing environment, taking advantage of the ecological opportunities presented by the mass extinction event. By studying the survivors, we can better understand how life on Earth has been shaped by catastrophic events and how it continues to evolve in the face of adversity. The Chicxulub Crater is named after the nearby town of Chicxulub Pueblo, which is located about 105 miles or 170 kilometers from the crater's center. When the asteroid hit, it created a circular feature known as an astroblite, which is a structure that forms from the collapse of rock inwards due to the impact. However, over time, this original crater filled with water and sediments. Researchers used various techniques such as gravity measurements, magnetic readings, and seismic surveys to map the crater's structure. A study published in 2007 revealed that the crater is roughly 110 miles or 180 kilometers in diameter and 12 miles or 20 kilometers deep. Despite its immense size, the crater is not visible from space. So when it was first discovered, many people doubted that it was really an impact crater. Some even suggested that it could be a meteorite that had landed without exploding. Over the years, scientists have conducted numerous studies to confirm the crater's origin and understand its formation. They analyzed the geology of the region and discovered shocked quartz and tektite deposits, which are found at other impact sites. These findings provided evidence that the crater was indeed formed by an impact event. Now, the asteroid didn't just cause massive damage to the Earth, it also created a massive crater. The Chicxulub Crater is now the second largest confirmed impact crater on Earth. The largest is the Vredefort crater in South Africa, which is about 186 miles or 300 kilometers in diameter. When the asteroid struck, it left behind a crater that was over 100 miles or 160 kilometers across, and about 20 miles or 32 kilometers deep. Today, the crater is mostly submerged beneath the Yucatán Peninsula, but its presence can still be detected through geological and magnetic surveys. Scientists have proposed various methods for locating the crater, but one of the main challenges has been the lack of a clear surface expression. This is because the crater is covered by a thick layer of sedimentary rocks and soil. Over the years, researchers have explored different methods to locate the crater, such as using radar, gravity measurements, and magnetic surveys. One study published in 2007 used seismic data to create a detailed map of the crater. The study revealed that the crater is about 110 miles, or 180 kilometers in diameter, and 12 miles, or 20 kilometers deep. Another study published in 2016 used high-resolution, bathymetric data to map the subsurface geology of the crater. The study revealed that the crater is filled with water and sediments, but it also contains a central uplift feature that is surrounded by a ring of faults. Recently, a group of researchers revisited the crater to collect new samples and conduct further analysis. They focused on a specific area known as the Chicxulub Pool, which is located in the western part of the crater, using advanced drilling techniques. They extracted sediment cores from the pool and analyzed them to reconstruct the geological history of the crater. The researchers found that the pool contains a unique sequence of sedimentary rocks that were deposited after the impact event. These rocks provide valuable insights into the environmental conditions that existed in the crater following the impact. One of the key findings of the study was the discovery of rare minerals that formed as a result of the impact. These minerals, such as Coesite and Stishovite, typically found in meteorites and provide evidence of the extraterrestrial origin of the asteroid. Coesite is a form of silica that is only found in meteorite impact sites. These minerals are created under extreme temperatures and pressures, which are similar to those experienced during a meteorite impact. The presence of these minerals in the crater suggests that the asteroid was composed of silicate material, which is consistent with the composition of chondrite meteorites. Another important discovery made during the recent study was the identification of shocked quartz. Shocked quartz is a type of quartz that has been subjected to intense shock waves, which can occur during a meteorite impact. The presence of shocked quartz in the crater sediments provides further evidence of the impact event and helps to constrain its timing. Shocked quartz typically occurs in meteorite impact sites and is characterized by a planar deformation feature known as planar fractures. These fractures are thought to have formed due to the rapid release of energy during the impact event. Overall, the latest findings from the Chicxulub crater provide valuable insights into the nature and impact of the asteroid that caused the mass extinction. 66 million years ago, the discovery of rare minerals such as Coesite and Stishovite, as well as shocked quartz, provides strong evidence of the extraterrestrial origin of the impactor and the extreme conditions that existed during the impact event. As researchers continue to explore the crater, they hope to learn more about the composition and origin of the asteroid, as well as the environmental conditions that existed in the aftermath of the impact. It's interesting to think about what would happen if another asteroid were to strike the Earth. Would it have the same devastating consequences as the one that killed the dinosaurs? Or would life find a way to adapt and survive once again? It's possible that smaller asteroids have struck the Earth in the past and may continue to do so in the future. But most of them go undetected because they are small and burn up in the atmosphere before hitting the ground. However, larger asteroids pose a more significant threat. According to NASA, an asteroid that is about 30 to 50 miles or 50 to 80 kilometers in diameter strikes the Earth every 1 million years. An asteroid that is 600 miles or 1,000 kilometers in diameter strikes the Earth every 100 million years. And an asteroid that is 1,200 miles or 2,000 kilometers in diameter strikes the Earth every 1 billion years. If an asteroid were to strike the Earth today, it would likely have a devastating impact on human civilization. The damage would depend on the size and composition of the asteroid, as well as its impact location. A large asteroid that is rich in iron and nickel could cause widespread destruction through its impact energy and the release of toxic gases. The impact would generate powerful shock waves that would travel around the globe, causing buildings and infrastructure to collapse. The airburst of the asteroid's atmosphere would release enormous amounts of energy and debris, leading to global wildfires and the formation of impact winter. This period of global cooling would last for several months or years, blocking the sun's rays and disrupting climate patterns worldwide. Such an event would have catastrophic consequences for human society, potentially causing widespread crop failure, famine, and mass extinctions. Even a smaller asteroid that is rich in carbon and other volatiles could cause significant damage through its impact energy and the release of greenhouse gases. The impact would generate powerful shock waves and tsunamis that would cause widespread destruction along coastlines. The airburst of the asteroid in the atmosphere would release enormous amounts of energy and debris, leading to regional wildfires and climate disruption. Such an event would have severe consequences for human society, potentially causing major crop failures, regional famines, and mass extinctions. The impact of an asteroid on Earth is a rare but potentially catastrophic event that has the power to devastate our planet and alter the course of human civilization. It's important to continue monitoring near-Earth objects and investing in asteroid detection and deflection technologies to ensure the safety of our planet and its inhabitants. What do you think? Do you think the world would end if another asteroid struck the Earth? Let us know in the comments below. Thank you for watching. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe so you don't miss any of our future videos. We look forward to seeing you next time.